Hello, my name is Konstantin. I work at Twilio. I'm a software engineer, and today we talk about AI. And I have a question: who is using AI? Okay, pretty much everybody. And who is using AI through APIs? Okay, and who is using it on production? Not too much. Okay, and maybe somebody is using it through JVM, Java, or Kotlin? Okay, so most of people are using Python. Yeah? No?
How to answer this question?
Sorry?
How to answer this question?
I don't know. Probably most of the people. But okay, I wanted to play with a library called LangChain4j. It's not exact clone of LangChain framework for Python, and it's Java framework. And I wanted to play with some playground. And what could be a better playground than a game? So I started writing a game. You may open this is a repository, and let's run. Sorry. Yeah.
So we should skip.
Oh, sorry.
Should we try to open that QR code?
Oh yeah. Please. All right, so we have an island. And on this island, we have a person, a player. I can control him, and he can go. And there are some persons living on this island. And they are artificial intelligence persons. So first one is Grook. He is an orc, but he loves poetry. So when player approaches AI person, then they start communicating. So let me ask, so if Grook is a poet, he should probably know how to write a haiku. So yeah, so it answers, and probably you expect that under the hood there is OpenAI answering these questions. So let's ask what else can you do? So he knows something about crab who lives on the island, but let's ask him to play a game. So it wants to play a game, question and answer, and he wants me to bet some coins. I bet 10 coins. Yeah, and he asks what is the color of the Alex the crab. I know that he is orange because I wrote the prompts. Yeah, and I'm lucky. And now I got 10 coins. So now you have 110. Maybe not correct, but this is AI assumption. Okay. let me ask him to, can you do math? Yeah, it can add, subtract, multiply, divide, but they are hallucinating actually because they can add and then can multiply and they can take a square root. I don't know, some number. And yes, it calculated something. And okay, let's leave this person, go away, and then come back. And I ask, what was my previous question? Yeah, I obviously asked about the square root, and it has this history, and the chat is basically here. All right, now let's leave this person alone and go to this grub. And I want to ask him what is current temperature. The sea. And it's thinking, and it says it's 27 degrees. All right, and then let me leave this one and go to the next one. So it's a dwarf, and interesting that he is not replying all at once, but he is replying word by word. So you see, answers, replies are coming word by word. And also, I want to ask him about, maybe he can reveal what can he do. What functions you have? What functions or tools do you have? And he answers that he has some magical tools, but can you calculate a root? Yeah, but how to get from Tartu to Tallinn, Estonia? Oh, this is interesting. But let's ask another question. The top rated in this is really interesting because actually he should be aware of different places. And Let me ask another thing. What is the time in Tokyo now? At least it knows what's the time in Tokyo, and it gets it from external sources. I have two Docker containers running, one with a Google Maps API and another with a time service. And we can see that this that AI asks time service to provide information. This is called tools or function calling. So let's get back to our slides. So we have an AI person, and it has some instructions given to him. It has personal knowledge. It has a knowledge about the world. It has a chat memory. So the previous conversation between player and the AI character, and it has some state. When it gives coins, so it has 100 coins, and it can give me 10, and so his balance is now so 90, and my balance is 10. So what I used to build this game? I used a library called libgdx. This is a cross-platform library to build games. It's possible to build desktop version. It's possible to compile it to Android and for mobile and for iOS, for web. But I used only for desktop use case. And also I used Kotlin and I used LangChain4j. So the typical use case is when player asking AI character is sending requests to LLM, and LLM replies back. All good unless LLM is having problems. And this is a case for real production environment. So OpenAI from time to time may have higher latencies, for example. And in this case, we need a second LLM as a fallback. So we're going to have two LLMs and maybe even more. So we need a level of abstraction. And we need some framework which provides this level of abstraction so we can decouple our business logic from integration with LLMs. And we can switch from one LLM to another LLM whenever we need. And the framework should provide these abstractions. LangChain4j has a thing like API called AI services. It's a declarative API when you can define your define your interface, and with annotations you can also define prompts and the tooling you want to use. And also the framework should provide knowledge to language model, so language model can answer these questions about our world, the AI character living in. But the problem is we may have a lot of knowledge, and language model, they operate with tokens. Token is a representation of word in a multi-dimensional space. So every word has a meaning, and there is a vector called embedding vector, which is like a point in this multi-dimensional space. And words with a similar meanings have vectors which are close to each other. I recommend watching the video. I will provide link in the last slide. And you can play also with this app. And you can tokenize text, so split text into tokens. How it's seen by LLM. And in order to split a big knowledge base into smaller chunks, we need a flow called retrieval augmented generation. And this flow has two steps, indexing and retrieval. So on indexing phase, we are splitting document into smaller chunks. It could be paragraphs, it could be sentences, it could be the whole document. And it depends very much on the kind of information you providing. So maybe it's the whole PDF document. So there is algorithms, like different strategies to split text into segments, and then we call embedding models. It's special language model which is returning these embedding vectors. And so for each segment, we get the embedding vector, which is actually a meaning, semantic meaning of the text fragment. And these embedding vectors, along with the text, we store in the embedding store. It's a vector database which is optimized for retrieving documents by vector similarity. And when we ask query, like we ask our AI person about something, we need to provide information to LLM, so LLM can use this information to answer the question. And the first step, we take a query and calculate embedding vector of the query. So we get the vector which defines the meaning of the query, and then we find in a vector database another vectors which are close, so we get the relevant segments which is relevant to this question. And then we send these relevant segments along the query to the language model. So our AI services is sending query to embedding model, retrieving some information, and then sends this information to LLM. Let me maybe show the how request looks like. So when I asked grab, I said hello. Then, okay, we have a system prompt which defines what is the character profile. And I instruct LLM how it should behave, how it should answer, and it gives information about the character. So this system prompt is always sent to the LLM. And then, okay, it's moderation. Oh, where is the last request? At the end. So when we send request, we also send information retrieved from the knowledge base. And language, LangChain4j, the framework, it appends automatically this information to the user request. So this is generated programmatically, and this is added by the framework. And now we have something new from OpenAI. It's called Responses API. So this they actually implemented API and allowing us to upload documents and use these documents without implementing this retrieval workflow ourselves and without implementing indexing workflow ourselves. So we're sending documents and we can ask questions about the content of the documents, and also we can group these documents into a vector, into a set, assign identifier to this set of the document, and ask OpenAI completion to answer using these documents. So this simplifies implementing RAG patterns, but it's implemented in OpenAI. Different providers, I guess they will come up with similar solutions, and probably they will replicate the API, because what happened with the completions API? OpenAI created this API, and many other providers started to follow the same API shape. So now, if we have a chat memory, the framework also including chat memory, so previous conversation, into request to LLM. And also, we may have some tools or functions, for example, sensors or time or current geolocation. So LLM is not aware of this information, or it could be stock prices, for example. So we instruct LLM that we have these tools available, and you may ask these tools to provide your data, and then LLM can use this data to answer initial question. And about 6 months ago, Anthropic has introduced Model Context Protocol. And this protocol is becoming a standard for integrating different data providers with LLMs. They have the host in this diagram is the application running LLM integration. So my game is the host. LLM client is aware of the information that can be provided, and the MCP server is actually providing this information. There are two transport protocols at the moment. It's HTTP server sent events and inter-process I/O, like std in, std out. And there are a lot of like reference server implementations and third-party server implementations, like official. You can find it in this site. And there is a third list which would not fit in the screen. So it's unofficial implementation of some service providers. So, for example, Google Drive, Google Maps, memory, different databases. And this is an example what information is provided to LLM. So when we ask this MCP server to tell us what information can be retrieved. For example, it can convert time between time zones. It can do many other things. Let's restart the game. So we have a fresh logs, right? And I go to this guy, and I want to see the requests. So in the request, there is a system prompt, there is a user prompt with information, and there are functions. So it's a tools element. Come on. Yeah, tools element specifying which information is available for LLM. And we provide every parameter description, and it's basically JSON schema. Right. So why we want to run AI workloads on Java? Because maybe we have already application running on Java and we want to integrate it. We have a service and we want to get some LLM assistance for our customers. Maybe we cannot run Python and JavaScript. Maybe we are running on the Android devices, for example. Or we have JVM as organizational choice. Our team JVM. We have a JVM shop. And we have a few options. We can use LLM clients provided by LLM providers. There are a lot of SDKs available. For example, for OpenAI, for Anthropic. We can also use some third-party Java or JVM client. If we are running on Spring, then there is a project called Spring AI. It's a natural choice for enterprise and for companies running Spring because it has good native integration with Spring and Spring Boot. It supports multiple LLMs. It also supports sophisticated workflows, and it has observability features which are very important for production use cases. And another kid on the block is LangChain4j. And if you don't have Spring and don't want to use Spring in your application, then this is an obvious choice. It also integrates with Quarkus, but it also has a Spring, LangChain4j Spring library integration, so you can use it with a Spring as well. And also, if you use some uncommon or not very popular LLM, then probably LangChain4j has this integration. For example, with a lot of Chinese LLMs and vector databases. And the community is more active, and there is a good chance that you can find your integration in this framework. And why you may want to use it with Kotlin? Because Kotlin is very good for writing domain-specific languages. It has very nice syntax, and it has now pointer exception safety. And you can also wrap synchronous code into coroutines, so it will look like, you will you can wrap blocking code into asynchronous coroutines, so blocking code will be actually executed asynchronously, but it will look like synchronous. For example, this is standard LangChain4j API to call language model. We have a chat, we have a builder object, but we may want to get it like this. And to implement it, we need so-called function type with receiver. So we have a method which accepts a lambda, and inside we create this chat request builder. Then we provide this builder to the lambda, and lambda sees it like this object. So this is a method messages defined in the chat request builder. And then we can also use extension functions. Extension function is a function that you can add to your existing class. For example, you can extend a class string with some other functions. And this is extension function for chat language model Java class. What happens under the hood, it generates a static method where the first parameter this is actually an instance of chat language model. But Kotlin compiler hides it from you, and you can call it like this. So you have a model, and then you call this new chat function on this object, and then you provide the builder is provided, and you configure your builder. So it looks very clean and nice. And a few more examples. Okay, oops. Yeah, here. Examples about asynchronous code in Java. So how we typically do asynchronous calls. For example, we use completable futures. We provide lambda, which may block thread, or it's just slow. And then we run it in the executors. And then we need to run another function after we received this result, and another function, and then we are done, right? And we can make it cleaner, like this. To make it cleaner, we need to define functions which are returning completable future. Okay. But what if we need conditions? For example, here, after calling API, we want to continue if we get by, or we want to stop if we didn't get by in a response. So here we can throw exceptions and then handle exception at the end of the call chain. And this is difficult to reason about. If you have many calls and many conditions. So how we can do it in Kotlin? So in Kotlin, the simple scenario reads just like synchronous code. But these functions are actually suspend functions. Suspend function, it's the Kotlin compiler generates a state machine, and it executes this function and suspends the thread and makes it available to other operations. And it suspends it unless this function is finished. And then it executes whatever is after this function in the code. So actually, it looks like callback. So we have something like this. So after call API is done, take everything else and execute here. And then after process data is completed, take this and execute. And this is also a suspend function, right? So it will be internally something like that. But compiler optimizing and hiding this machinery from us, so we can basically run it. Okay. Come on. Oh, okay. I've broke the code, and again. So it took 3 seconds because we had delays. And then if we have if conditions, we can write it very easily, and it's very readable and clean. All right. And now something about testing. If we want to run tests on production, it's not good. So we have to test on stage and development environment. And if we want to test with LLMs, then we get non-deterministic responses, because LLM may sometimes hallucinate. And also, LLM may not be available because of some outage. Also, it costs money. So every run of the test is consuming tokens, and you are paying for these tokens. Also, if you want to have it in a continuous integration CI/CD, then you have to take care of your budget, of your account. So from time to time, you have to refill balance. Otherwise, your CI/CD pipeline will break. And also, language models have rate limits. So you cannot run many tests in parallel. So you have to do throttling just in your build pipeline. Or you'll have some flaky tests, and you should be OK with that. But also, you may want to simulate negative scenarios. For example, LLM is not responding, or responding slowly, or responding with garbage. You cannot do it with real LLM. With LangChain4j, there are some mock chat language model. So you can call this model, and this is something like a unit, like Makito. Or you can actually use Makito, or you can use this. But for my use case, I wanted to create something more closer to real life. I wanted to do a black box testing. I wanted to have fast deterministic tests for free. It should work in CI/CD. It should simulate negative scenarios, and it should support server-sent events. Because I was unable to use WireMock, because WireMock doesn't support server-sent events. So now I created this mock. So there is a moxie, which is basically a rewrite of WireMock. I didn't want to do it intentionally, but I ended up rewriting my WireMock. And then I implemented mock OpenAI for completion request, and also there is anthropic messages endpoint. So I configure when user message contains expected text, then LLM should respond with expected response. Maybe I can show it. So I just need to provide a language model with my server base URL, and it should run against my service. But if I comment out this, it will run against the real LLM. And it actually didn't respond what I expect. I expect LLM, but it answered large language model. And that's why my test has failed. So this is non-deterministic. And how I can run streaming use case. For example, I want to simulate slow response from LLM. So I instruct my mock to answer slowly with delay of 1 second between chunks. Oh, let me try again. Yeah. So we see the responses coming word by word. But if I remove it, then I can run my tests pretty quickly, 200 milliseconds. Right. And let me show you how we can run this complex RAG workflow with LangChain4j AI assistant. So we have, no, not here. I defined the assistant interface. It has one operation. It accepts a parameter which defines the player name, and this is it becomes it defines a history of the conversation, and then it accepts a user message. It's actually a question, and it can accept back from LLM an object. So we can ask LLM to provide a structured response back. For example, when we ask AI character to give me a coin, I want to get back amount of coins as integer. So let me run this test. I will run it with real OpenAI. And before I run a query, I take some knowledge. I prepared some text, and I use utilities provided by LangChain4j to load it and to create in-memory embedding store. There is embedding store content retriever, which is used when we ask queries, so it provides document fragments. Then there is a chat memory. It could be a message window. It could be token window, how much information we want to store in memory. Like, for example, maximum 10 messages. And we want LLM to respond with the JSON, and we provide a JSON schema. And JSON schema is generated from this POJO. We provide description. What does this field means? So when we run the test, let me run. So how request looks like, this is a, again, this is a system prompt. This is my question, and then it augmented with data. And then I'm asking for response format JSON schema, and the JSON schema is generated and provided. And then I get back response, and this is actually a JSON. Yeah, so it has a text and coins. And also, if I want to do some scary thing, for example, I want to abuse and threaten LLM. So there is a moderation model as well. And moderation model is called before you send data to LLM, and let's do an example. So the results, there is no harassment. It's for stop violence. Flagged true. So it is violence because I said I will kill you. And my test expects moderation exception, so I receive moderation exception. My test is green. So we are protecting LLM from abuse and also customers.
What you said for harassment?
Stop. What I said? I said violence. But it says that there is also harassment. I don't know. It's not me. It's LLM. It's hallucinating. Or there might be a reason. Yeah. All right. Now stop. But it didn't took my coins. Yeah, so this means that we caught exception, and actually it no, this is my logic, my custom logic. So if I receive this exception, I deduct 50 coins, but I don't say here in the interface that this is my game machinery. So for the user, it's like org did it. So on production, we have these kind of challenges. We have high latencies. LLMs may not be reliable from time to time, so we need fallback options. We need also validate user input, and because user may want to do some prompt injection. If you are using SQL as a tool, then it's possible that user will try to do SQL injection through prompt. Also, we want to avoid sharing sensitive customer information with LLMs because LLMs maybe not guaranteed to protect this information, and we need to monitor our token consumption. So that is it. On this QR code, you can find a page with the links, and you can send me a message. Thank you.
Questions? Do you have some questions?
Yeah, on moderation. So how does moderation work? So it's also used on LLM.
Yeah, there is a moderation model. You can find the moderation endpoint in OpenAI. So these are the models specially trained to detect different kind of abuse, and they return a score.
I see. It's like a separate endpoint.
Yeah, it's a separate endpoint, and LangChain4j, and I don't remember about Spring AI, they provide abstraction for moderation models.
Also, I wanted to ask about these LLMs. They usually have limited context. Like you can only talk with them for a while. So imagine in this game, if you like chat with this squirrel for a while, will it start forgetting?
Yes, it will start forgetting because we have a chat window, and chat window size is defined. It's fixed. So it's like event horizon, and after that, it will start forgetting. There is a technique for summarizing previous conversation, so it wouldn't forget completely, or it will leave some traces of memory, but without full details, of course.
Thank you.
Yes?
You mentioned the security aspects as well. So I would ask if LLM run on premises, so locally, is it automatically safe or still not?
Probably, yeah, it's much, much better. But you should probably take care of prompt injection thingies as well. But if you control all your data flow, if data is not leaving your premises, then it's fine.
Okay.
But ask your security department.
I have a question and statement. So let's say you want to publish your game at Steam, and you don't want to use API integration. Is it possible to, let's say, download arbitrary model from, let's say, Hugging Face, some suitable size, I don't know, 5 gigabytes, who cares nowadays, and embed it into your project, and let's say, and publish at Steam?
Yeah, you can use Alama language model from LangChain4j, Alama integration, so you can run your LLM locally with Alama, and LangChain4j model, it's actually interface to your model. It will connect to Alama, and you can run it locally.
And second statement, tests that you showed, they doesn't really catch behavioral aspects.
Yeah.
Just a proposal. You can think about word embeddings if you have access, and maybe you can simply calculate maybe average, and you don't care if the phrases are completely different, but you can estimate the distance, this cosine or whatever.
Yeah, it's two types of tests, functional tests, and like when you test your HTTP clients and how it does parsing and how it does handling like rate limits, network issues, and other kind of tests actually testing LLM integration. And this is very important because if you are integrating with OpenAI, they may change their model, or you want to try a different model, and you need to run these tests to verify that your prompts are correctly understood by LLM still. And maybe you want also to have A/B testing for your prompts. There is also a need for this kind of tests.
Thank you so much. And the last statement, just the minor, it feels that we don't really communicate with LLM as there is extra engineering layer that classify your prompts and maybe modify requests. We don't really know the certain architecture. Like, actually I was thinking about embedding LLM. That seems the way forward because at least you will control model behavior more or less.
Yeah, but
you get static model, download, embed, and you can build some testing around it. More or less basically.
Yes, but it will consume my compute resources. So if I want to run it maybe on mobile device, I will have to communicate with a remote model. But maybe for mobile device, it's even better to use some API and build the LLM integration on server because I will have control. Because on mobile device, someone has to provide API keys.
Yes, someone.
Yeah, so it's basically a user. User should provide their own API key. And if we want to productize it, then we need to deploy it on server and have a subscription. So we collect money and pay to LLM something and leave something to ourselves.
And actually consider that your model would be really small, I don't know, 100 megabytes. It will just do just a certain, it will be trained just for specific problems. Like given the simplicity of your game, we can really make characters kind of distinct, but yet more or less predictable with the model.
Yeah, it's actually a good idea to chain models. So first we, or for different tasks, or maybe for different states in the state machine, we may use different models and we may use different prompts. For example, if my character is in the poetry mode, it's using one LLM, and then we want to switch them to coding mode, and they need the different LLM. So it's basically switching a state, and there is a LangChain4j project. There is a LangGraph for Python, and like a clone or similar project for Java, LangChain4j, which is handling these state machines and transitions.
Okay, let's have like I guess last question.
What happens if you are not good enough on filtering input or output from the LLM model when user is trying to convince character, for example, in your game to hallucinate on demand, or is convincing a hero like trap is not a trap and it's a bird. And, what are those scenarios if input is some kind of on demand, not pre-programmed and cannot be used as a correct output?
So for this game, maybe no harm, right? Because this is a game, you are playing it. It's a playground, actually. But if you are doing LLM integration on your company, then if you are using tools, for example, and user will try to do some SQL injection maybe a tool is using SQL, which is a bad practice. Or maybe it will try to reveal some internal instructions. Or if you are running fully automated workflow, for example, it can give you some discounts, then user may try to hijack prompt and get the discount. So.
Okay, you can ask meanwhile questions while others are eating pizza. Usually we give a little present for you.
Oh, thank you.
Exercise.
No, this one.
So thank you for your talk.
Thank you.